There are a wide variety of etiologies that cause heart failure. Heart failure patients experience a progressive loss of exercise capacity and the ability to perform daily activities, which leads to a significant diminution of their quality of life. The phenotypic measures of worsening heart failure are well known and can be observed using standard measures including left ventricular ejection fraction and end diastolic diameter. In patients with chronic heart failure, myocardial gene expression shifts from a normal profile to an abnormal heart failure profile. When this occurs, some genes become abnormally downregulated and others are abnormally upregulated. Some of the proteins associated with these genes are essential to normal calcium cycling and myofilament function, which collectively determine myocardial contractility. Halting or reversing this shift is one of the effects that has been shown to occur with cardiac contractility modulation, or CCM therapy. In a normal cardiomyocyte, the cell membrane is depolarized as the action potential begins. This depolarization of the cell membrane triggers opening of L-type calcium channels on the cell surface, causing entry of small amounts of trigger calcium into the cell. Shortly thereafter, the ryanodine receptor calcium channels located on the membrane of the sarcoplasmic reticulum open, and calcium ions flow rapidly into the cytosol. Calcium binds to troponin C, which leads to a series of conformational changes of troponin I and tropomyosin, which ultimately exposes cross-bridge binding sites on the actin filaments. Cross-bridge cycling ensues, generating force via thick and thin filament movement. To initiate relaxation, calcium ions are pumped back into the sarcoplasmic reticulum. This occurs due to the presence of the sarcoplasmic endoreticular calcium pump, or SERCA2a. Importantly, the activity of SERCA2a is regulated by the phosphorylation of phospholambin. When phospholambin is hypophosphorylated, it binds with SERCA2a, which reduces its ability to reuptake calcium, thereby reducing the amount of calcium available for contractions. Genotypic shifts in expression for proteins such as SERCA2a, alpha-myosin heavy chain, and phospholambin contribute to decreased contractility and global ventricular dysfunction in heart failure. CCM therapy has been associated with reversion of key gene expression back towards normal profiles, which collectively improve myocardial and global LV function. Within hours to days, this beneficial shift of gene expression is observed in the region of signal delivery. Effects are observed globally within 3 months. Like the inotropes milrinone and dobutamine, CCM augments contractility. However, in stark contrast to these medications, CCM has been found to exert its effects without increasing global myocardial oxygen consumption. While certain aspects of the underlying mechanisms of action remain to be clarified, there is sufficient evidence to conclude that CCM treatment exerts both short and long-term beneficial effects on the failing myocardium. By positively affecting calcium handling and halting or reversing maladaptive changes in myocardial gene expression, which can lead to reverse remodeling. For more information, contact us at thebeat@impulse-dynamics.com or take a snapshot of the QR code shown here to obtain additional information.